All right, let's get started. It took a little bit of time to get set up here. Balaji is going to walk you through the flight test assignment. And then I'm going to lecture after that. So this is an X-Plane, and he'll go through the details of finding the software in here, in the lab, and how you do this. All right.
Thanks. Oops, that's right.
It does have a clip.
Okay, I was trying to see that too. Hello, everyone.
And you're probably going to have to speak up.
Oh, sure.
Not everybody in here is on Zoom.
Sure. Hello, everyone.
You have to keep your mask on.
No, no. Yeah, that's fine, sir.
Yeah, you just have to shout.
Sure. Hello, everyone. I am Balaji Karthikeyan. I am a graduate research and teaching assistant of Dr. Steck. I've been working with him since 2014. And I've been working on various research topics, but in 2017, I got a chance to join Bombardier as a flight test engineer intern. And we wanted to bring a taste of flight test and to also show you guys on how a flight test world generally goes on. To kind of introduce you to the concepts of flight test and how we go about things, and maybe introduce you to a few technical side of flight test. We will have approximately 4 assignments, 4 or 5, and we will go, each assignment will have its own objectives, and you guys will team up and prepare a report and submit it for in Blackboard to be graded. So the first assignment is, our objectives is mainly to get familiarity with piloting an aircraft and explain. How many of you here are pilots, like have a piloting license? 1. Okay, so that's good. That's exactly what I wanted to introduce you is to get the feel of flying an aircraft and explain. Of course, you will not be following any checklists or anything like that, but you will be taking an aircraft up in the air and collect some data from it. And also the basic introduction to flight test engineering. So the first step, of course, is the resources. You can use any of these 10 machines up in this desk, except for machine 8 for now. Everything else has X-Plane 10 in them. So, and the local username and password is given in the assignment. So if you sign in, it will log you into this local machines of only from 1 to 10, not in those ones, not in the machines 11 to 32. So you can log into this, but do remember, if you restart or shut down, any changes you make will be lost. This is the very first thing you have to keep in mind. And then we go to the report structure. Of course, I've asked here 1 report per team of 2. I don't know how many total students are in the class. Total. Okay, so it works out.
He's saying you need to pick somebody you're going to partner with to do this.
Yeah. The reason why we are a team of 2 is 1 will be piloting the aircraft, and the other person will be noting down the data if there is any. And also to kind of interchange the roles, and so that the other person can fly other test points while the second person notes down the data. And majority of the times, flight test engineering is a teamwork. It's not one-man show, and that's pretty much the idea here, to form teams. You have to have 3 output. The output items 1, 2, and 3 should be in a separate table of their own. We will talk about them as we go forward. And both the team members should have flown almost equal number of points. This is just to make sure that you go through the nitty-gritties of roles of a pilot and an FTE. Both of the members go through both the roles. My office hours are currently non-existent, but I am available through email. I usually am pretty quick in replying. So just drop me an email, and if we do have to meet, then we can set up a time and place, and we can meet while socially distancing ourselves. And also, please, this is new thing for this particular semester. Follow all COVID-related regulations and suggestions, both by WSC and CDC when using the lab, including but not limited to wiping down the workstations after you are done with it. Of course, since I think you get almost 10 days to complete this assignment, so you're free to drop by anytime, but do make sure that you wipe down, and I think you have the disinfectant and the paper towels there for that purpose. Okay, going down to the problem. So we have, you're basically going to fly two aircrafts. One is going to be a Cessna 172, and the other one is going to be a Boeing 747. And the given conditions are the Cessna has to be flown at 5,000 feet cruise condition, and it is to be flown at the true airspeed of 75, 100, and 130. And Boeing 747 has to be flown at 350, 399, and 450. The main reason is to like give you a feel of a GA aircraft and also a heavy metal aircraft. And one thing which you have to notice here is that the speed mentioned is in true airspeed, which of course is not flown by the pilot. The pilot flies what we call as an indicated airspeed, or sometimes they also call it as corrected airspeed. Do you know the difference between indicated and corrected airspeeds? So indicated is what, usually what it means is that your pitot tube measures air velocity at the nose or at the wingtips, depending upon which aircraft you're using, but the pitot tube is not exactly at the CG, it's placed somewhere else. So you correct it for that, and also for some errors coming because of the material itself. So anyway, so you'll be flying in indicated airspeed, and the conversion from indicated to true to indicated or vice versa is given below. If the speed flown is less than Mach 0.3, then you follow this equation. And if the flying Mach is greater than 0.3, then you have this more involved equation. Here, you can all assume, you can use the standard atmospheric table for any of the unknowns, like static pressures especially, and also densities. So don't worry about what time of the day it was or what temperature, just go by the atmospheric table. And one thing is whenever you get into flight test thing, is that you will never hit the test point you want. I mean, the flight sciences always wants you to hit that exact point in the envelope, but you will never meet it. So you will always have a tolerance. So the tolerance for us is like you always maintain a wings level flight, and it has to be, the level flight has to be maintained for 5 seconds before you collect data. That is to make sure that you are not going through any transients. There is no rates or anything, so you have to stabilize for 5 seconds. The pitch can be should be 0 degrees, but it can be plus or minus 5. And the sync rate or the vertical speed should be 0. Of course, 0 is awesome, but plus or minus 500 foot per minute is okay. And then roll, of course, is 0 plus or minus 5. And altitude should be really tight, plus or minus 200. So make sure that you're not like climbing through the test band or going or descending through it. And the speed should be plus or minus 2 knots indicated. So any questions till now about how we are going to fly this test point? So all you are going to do is put the aircraft in KICT, take off, climb to the cruise altitude, and then do the 3 different speeds, collect whatever the data is required after this, and then switch to the next aircraft. Any questions till now? Any doubts? Okay.
Do they take the target airspeeds and convert it to indicated?
Yes.
And fly those?
Yes, sir. And the thing is like you never fly true airspeed. I mean, when the data is reduced, they convert all the indicated airspeed to true airspeed, and then they do all the calculations. But a pilot always flies indicated.
No, but what airspeed do you want them to, like you
And in the fly, so they'll be flying indicated, but I'm giving them true airspeed.
when you say 250, you want them to fly 250 indicated?
No, 250 true.
250, so they need to
Convert it into indicated.
and then fly that.
Yes, sir. And I've also given them the equations to
Yeah,
do the
no, that's
conversion.
fine. I just wanted to make sure they were converting it before they fly.
Yes. So you create what is called a dance card. I mean, dance card is something which, so when you are planning a test point, right? I mean, I'm doing a flight test tomorrow in an eSIM. So what we are doing is we are doing a maximum takeoff weight takeoff, and then we are going to land at a maximum landing weight, and then we are going to shift configurations to a light aft, then we are going to take off and land again. So when an engineer writes a test report, they won't exactly think about, okay, I mean, I should do the takeoff first and then do the landing. They just worry about, okay, just do this point, this point, this point, and this point. So dance card kind of helps you and helps the pilot to know and plan how to order the test points so that you are not wasting energy climbing and descending, so that you do all the test points at a certain band at certain levels, and then you climb up, or you do it while climbing down depending upon the test conditions. So you're going to create a dance card showing the test point number, which aircraft you're flying, altitude which you're supposed to fly, the speed, the true airspeed, the pilot and the FTE between the two of you. And so you'll have 6 test points. You have 2 aircrafts with 3 speeds each, so that's 6 test points. And then once you have done that, in the next page, you will have the table where you show the test point number. And then, so now at this point, you already have your indicated airspeed, which you have worked out either in the Excel or through hand calculations. And then you have taken off in the particular aircraft, you have stabilized at the cruise condition, and you have the speed, you have maintained it for 5 seconds. So the FTE has to note down the elevator position, the forward indicated airspeed as you are flying the test point. The forward true airspeed is, I think Explain gives that output. If it doesn't, then just enter whatever is you are supposed to fly. And then the Mach number also is given by Explain. And I think all 3 of these are given by Explain. And then you have the altitude at which you are flying. You should be flying at 5,000, but you won't. So enter whatever is the number shown by Explain. Then note down the sync rate, bank angle, and the flight path angle. So, of course, you have to show the true airspeed to indicated airspeed calculations. Either you want to do it by Excel or hand, it's fine. Just add it as an addendum to it. And plot the, you have an output data file. Of course, I'll show you how to get that. And using this output data file, I want you to plot the bank angle versus time, the sync rate or the VVI versus time, and the forward speed versus time for 10 seconds before your data collection point. So say, for example, I correct the data at 20-second mark. I want data to be plotted from 10 to 20 seconds. Basically, what you're seeing is you should see your aircraft stabilize. And that's the idea. Using these plots, you're basically trying to find out where your aircraft is stabilized. And usually, the engineers use those plots to figure out, okay, those were the exact times when the conditions were met, and they use that for calculations. And submit the data.txt file, which, of course, you will get from the output folder. And remember, I need only 1 submission from a team of 2. Any questions till now?
Can you talk about the point number?
The what?
The test point?
The test point number is going to be, for you, it's going to be 1, 2, 3, 4, 5, 6. Usually, in industry, each test point is recognized by its own unique number. But in this case, it's going to be 1, 2, 3, 4, 5, 6.
This is how many times we're doing it?
It's actually how many different configurations you're flying. So if you go to the exact problem, so you have Cessna cruising at 5,000 feet with 3 airspeeds, right? 3 true airspeeds. So that's test point number 1, 2, 3, and 4, 5, and 6. So each configuration is going to be a test point. Any other questions? Okay. So explain 10 instructions. I'm assuming you guys know how to switch on, how to start or execute the explain. Choosing the aircraft, you can go to aircrafts menu, open aircraft, and general aviation, and under that you should have a Cessna 172. You click that folder, you have a .acf file, just run it. And similarly for 747-400, you're going to use the heavy metal folder. For data collection,
Is that true that everybody in here has used explain before?
no?
Let's see if we can find, there's another computer that's hooked up to the projectors.
Do you want to find?
We can log into that.
Do you want me to?
One is one south.
I'll try the one north and see which one shows up.
That's one north.
Oh, one south.
Everybody logged in? Try west and south.
I don't think it's. Yeah. It's kind of. It's fine.
I'm guessing it's connected up.
Hmm?
I'll tell you what, go ahead and log out of my account here.
Oh,
and
sure, sir.
Log into the flights account.
Sure, sir.
So let's, you're gonna need this again, or have you gone through everything in here?
Oh, I just have a few more things to
Okay,
go through. So let me go through
and then we'll
this.
switch over to explain.
Sure. So I'll show you how to go to the data collection. It's in the settings, data input and output. This exactly shows you what you have to turn on. You have the times, you have the Mach number. I think the speeds will give you, we will see what gives you. I think it gives you the true and the indicated knots. And then pitch and roll headings, AOA, side slip, and all of this. And the reason why we are selecting only the disk file and the cockpit display is the disk file will help you. It will give you a .text file, which you can use to plot all your plots. And the cockpit display will help the FTE to know whether you're in condition or not. And one thing which I want you guys to know is keep the disk rate at 10 per second, 10 hertz, so that you don't have a very big text file to deal with. The output file will look something like that. And remember, before you start your explain session, delete the existing output file in the output folder. So that, and it's once you switch on the explain, it will start writing a new output file, and it will look something like this. So you have the indicated KIAS, KEAS, true, and then you have the V-true airspeed, V-true ground speed, and everything. And that's it. So can I? Sure. No, no, I'll just switch it.
You'll just log into the flights.
Sorry.
You'll log into the flights in the account.
Sure. Sir. Yes.